So in our UML for the music app, which does all the typical music app stuff, like letting the user create an account, log in, creating songs, playing songs. Probably the most important part is data loader and data writer, which is where pretty much all the information is saved and managed, stored, all that, so that it can be, used throughout the entire app and all that. Probably the most important interaction is with song, which is obviously the core box in the middle, where pretty much all the components like measure, note, chord, sheet, tab, which basically define the songs, they're all contained there. Obviously, song interacts with pretty much every other file, not file, but code, pretty much everywhere else. And then after that, it's probably its most important interaction is with like user list, and author, since that's what initially allows users to have accounts, exist, all that. And then the actual way the users interact with the app is with song application and song UI, which just lets the user actually start up the app and then continue onto song and then instrument, measure, note, whatever needs to be done. Along with that, you have the things like the enumerations and the interfaces, which help out other files and parts of the app so that they can function properly. And if you look at the code, you can see pretty much all of it in action. There's the data writer, fully typed, complete, does all the data storage and management it needs. Data loader does the same. Song takes all the music info it needs and whatnot. User does the same, but for all the user information that's necessary, which we decided was the ID. They still have a UUID for the user. First name, last name, their username, email, password, their favorite songs, and whether or not they're an author, which means if they can they can add or create songs. And then user list has a pretty good example of design pattern implementation since it uses the singleton design pattern.
Hi, this is Thomas Slutzloat. I am part of the Hermitz group, and I am here to showcase, uh, I guess, a scenario of a user uh, playing a song that is loaded in a song's JSON file. So, the way that this works is from our driver as we currently have it, there's a method play song, which gets an instance of the song list singleton, and within the song list, it searches for a song with a specific UUID, which this one that we have here is just pulled straight from what we have in the JSON file. And after that, it creates an array list of measures belonging to that song, and it iterates through them. And when it iterates through those, for each measure, it calls the measure method playNotes. And I want to explain a little bit more about how that works because it is a bit complicated. Uh, it starts with an empty string called jfugue argument, which is the string that will eventually be processed by JFugue into the actual sound that will be played. There's a max time integer variable, which is going to eventually be uh, a marker for essentially the latest start time of any of the notes in the measure so that it knows when to stop adding to the JFugue argument. And this voice variable here, this is to differentiate between what are essentially different channels when JFugue is playing sounds, so that if there happen to be more than one note that has the same start time, it will actually play both of them at once. It also creates a buffer array list of notes, which is essentially just keeping track of all of the notes that haven't been added into the JFugue argument string yet. It creates an iterator for all of the notes belonging to the measure, and as it iterates through them, it updates the max time to the latest start time so far, if it happens to come across that, and it copies each of the nodes belonging to the measure into the buffer array list. And this whole process from here on continues while the buffer array list still has uh, notes in it. Uh, it starts out by clarifying which voice in the JFugue uh, it is using, and then for every time that it does that, it in there is a for loop that increases in time as it goes, and it searches for if one of the available notes has a start time that matches that time. If it does, then it codifies that note into the JFugue argument, and if it doesn't, then it just passes and adds a rest in place of it. It's worth noting that if it does find one, it just stops checking, just in case there is another that would match. And that is why, at the end of that, it increments a voice and iterates again if there happen to be any remaining notes after it searches through all of the available times. And at the end of all of that, it instantiates a player, which finally plays the sound. And I almost forgot to actually demonstrate that, but here it is. Unfortunately, uh, with the JSON file as we currently have it, it is very bare bones. There is only one measure with one note, but I hope that I've made it clear in my explanation that it is very much open to expansion, and it should already be more than capable of handling much larger songs.
In this test, we will be testing login. Login will be able to take in a user's username and password and match it with a pre-existing account in users. In the login method, we are testing the login correctly and dividing it on a separate line and then showing the logging in with wrong. The user is found by a given input, I'm Spider-Man 99 with the password Spider-Man 2099 rules. This is our user Miguel O'Hara. Now, with the matching username and password, the system shall print the accessed user's ID, the accessed user's first name, and the accessed user's last name. In logging in incorrectly, a incorrect username and password of the going off of the same user Miguel O'Hara, if the user is null, then there shall be a print of a failed login attempt. In the terminal, we have the correct login of the user's ID, the user's first name, and the user's last name. Below this, we have the failed attempt to log in since there was no matching username with the there was no matching username to find a valid user, which would have been I'm Spider-Man 2099, while the entered was I'm Spider-Man, with the passwords not matching either. User list gets the instance which contains the list of the users in the JSON file. And what happens is when logging in, the system goes through the list of users trying to find a matching username and password until there is a match. Otherwise, no user is provided and a user is returned as null, explaining why wrong login user was null.
I mainly worked on the data writer part of the project, so I wrote a quick little scenario here that kind of shows the functionality of that specifically. So generally, starting with this one, we'll start off with the in the user JSON and the song JSON. They're both empty. We don't have any songs or anything in there yet. If we go to the driver, the first scenario there, see that it does in fact, let me just reorder that. It does in fact create the song and the user and it populates them into that. And also, just comment on this. Here's another scenario where you'll see that it takes all the info from the JSON, copies it, and appends the new info so that it doesn't just overwrite it, it actually saves the new data and adds to it. So that should have added a new song in there. Just reformat that. And as you can see here, there are now two. Just the general format of the song. I didn't go through and put all the notes or anything in because that would be very time consuming. But yeah.